Welcome back to more hypothesis testing basics with Dr. T. We're working on part 4. We are still working on determining a minimum sample size, but we now have a great confidence interval where we can say that with 95% confidence, the proportion of adults who support bail reform, the proportion of adults who support bail reform is between about 26.2% and 31.8%. So from what we've worked of our example problems so far, I've gone ahead and given us a little memory jog here. P hat, we've figured that out. Q hat, we got it. N equals 1,000. I think I changed that. I think it's supposed to be 1,011. Pretty sure. And our error was 0.028. We figured those things out, particularly to work on that confidence interval. So now, still working to determine that minimum sample size, we can just go ahead and plug in what we already know. And here's the formula. N is equal to P hat times Q hat times our Z critical value divided by the error squared. Go ahead and do that math. Once we've done the math, we can see that the minimum sample size we could have had was 1,009. So we meet the cutoff in that example. But all of that assumes that we had some idea of what P hat and Q hat were. What if we didn't know that? What if we didn't have that initial number of folks who said they support bail reform in the sample of adults? Well, we could use P hat equals 0.5 and Q hat equals 0.5 if we're working under a standard normal distribution. So let's go ahead and take an example of what we can do if we have to kind of fill in these gaps on our own. Let's try to figure this one out. You are running a political campaign for the sheriff. You wish to estimate with 95% confidence the proportion of voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Well, geez, that seems like not much information, right? Well, because we don't have a preliminary estimate for P hat, we can use P hat equals 0.5 and Q hat equals 0.5. Let's look again. Here is the minimum sample size formula. It's N equals P hat times Q hat. Don't forget, got that Z critical value divided by error. Those are squared. We can go ahead and plug in what we know from all of those words, and we'll have our minimum sample size. All right, let's just try it. So N is going to be equal to 0.5 times 0.5, p hat and our q hat. We know with this 95% confidence that our z critical value, and remember, you can get that from the z table. Most of the time, a z table will have the critical value somewhere. Z critical value 1.96 divided by our error, and they actually give us that. It has to be accurate within that 3%, so that's 0.03. Square that. All right, we're going to go ahead and do that math. And once you've plugged all of that into your calculator, you'll come up with probably around 1067.11. Well, we don't have 0.11 persons, so we can go ahead and just round up, even though it's small, to the next whole number. We're talking about people here. And our n, let's say round up, so you know what we did, round up. So our n needs to be at least 1,068 people. Oh, okay. So now that we have the foundation for testing a hypothesis, I want to give you a little bit of a cheat chart. So if what we're working with, our population parameter, if what we're working with is mu or a proportion or sigma, our standard deviation, then our test statistics, for mu we can use x bar, for p we'll use p hat, for the standard deviation we can use the little s squared, right? And then what test do we run? What test do we run to determine whether we reject or fail to reject our null hypothesis? Okay, well, when we're using a sample, we have a couple of options. We can use a z-test if our sample size is greater than or equal to 30. And we could use a t-test if our sample size is less than 30. If we're working with p hat, we are going to use the z-test statistic. And if we're working with the standard deviation, we're going to work with, you've probably heard this term before, the chi-square. Just returning to thinking about hypothesis testing again. If the null hypothesis is true, then the p-value, that stands for probability value, the probability value is the probability of obtaining a sample statistic that is as extreme or more extreme, as extreme or more extreme from the population. I'm going to say this a different way. I feel like this is just a confusing way to say this. Let me explain it a little differently. What we're interested, particularly in criminology, criminal justice, actually a lot of social sciences, is we're interested in knowing whatever it is that we're testing, right? What is the likelihood? We want to know what's the probability that if I'm using a sample that I have found something significant, I have found something that maybe rarely occurs, or I have found something that occurs within a very certain parameter that didn't happen by accident, right? So if you think about it, and we think about, like, here's our whole population, right? Whole population. And for billions of reasons, time and money and technology being 3, I can only take a look at, say, this many people out of the whole population. And what I find when I've gathered statistics on just this many people out of the entire population, what I find is that this many of them, whatever they are, that many of the folks, let's see, began committing crime at age 15. Well, that's great. I found that many folks out of all the pink dots that began committing crime at age 15. Here's the thing. Who cares, right? That doesn't necessarily represent the entire population, unless I can show that it can represent the whole population. And the easiest way for me to show that is by taking a look at a p-value. And what I'm looking to do is figure out on a normally distributed curve, because of course this is a random sample I took, of course, underneath this random curve, did I grab these folks from right here? Well, that's not significant. That's most everybody all the time, right? That's a lot of folks in here. Or is there something really special about them? And I had a really tiny chance of actually talking to those people who said they began committing crime at age 15. Is that significant? I hope that makes a little bit of sense. Now let's work some things out. So now we have an idea of the test statistic that we're using. And because we could be, using a z table, a t table, chi-square, we need to know what kind of test we're doing. Is it are we looking for our p-value to be where under a normal curve? So I'm going to give you a few hints, and then we'll work through just a couple little examples, and we'll move on. Now, if the alternative hypothesis, I've been doing H1, contains the less than